Sorry, it's a little late, but we're gonna start with this one because it's the easier one. Well, not the easier one, just so you're asked to find the distance between the 2 points. So one way and this one, we don't have anything to worry about in terms of units. So each square, right, is exactly 1 unit. So no, that's not the button. Okay, no, that's not the button either. Here we go. So let's do, I'm just not going to do many of these because you already know how to. So I'm going to pick number 5. I'm going to random ones. So number 5, we want this, and then let me pull that out to the side. So we're looking for that diagonal, right? So we're going to use the Pythagorean Theorem, and I need the legs. So here are the legs. Let me draw it out. So this is the leg, and this is the other leg. So we can easily just count. So there's 1, 2, 3, 4, 5. So this leg here is 5 units. The one going horizontally is 1, 2, 3, 4. So that's 4 units. And that's all we need to find the hypotenuse C, right? So these are legs, A and B. A squared plus B squared equals C squared. So we can, A squared is 4. B squared is 5 to the second power equals C squared. We're going to go 16 plus 25 equals C squared. That's 41. Take the square root of both sides. And C, for us here, is going to be rounded 6.4. Okay, so about 6.4. And that's, rinse and repeat for the other problems. So now, hopefully you'll realize that as you did this, let me pick a couple of others. Let me do one more. Let me do number 12. Right, so here again, we want this diagonal, and we needed this leg and this leg, right? And it was very easy to do. So now I'm going to do this. Well, actually, next examples I'll do it. But you had the point here, right? So, and let me just make the triangle, right angle triangle, right? So I'm just making a little bigger here. So up and down between the y-axis, this distance is 1, 2, 3. Between the x values, the distance is 1, 2, 3, 4, 5, 6, 7, 8. So this was 8. That's all I needed. I have now the legs. That's A, and let's call this B, and I need the hypotenuse. So again, A squared plus B squared equals C squared. So we got 3 to the second power plus 8 to the second power. 3 to the second power is 9. This is 64. C squared, that's 73. Equals C squared. We're going to take the square root of both sides. And C equals approximately 8.54. Approx. Right? So that's how you do that one. Now, the next section here is I'm going to spend a little more time. I'll take the first one, 13. So let's do 13. So if you look at 13, if I were to start this, I would draw a little graph here, a little coordinate plane, just so I can imagine where 7 and negative 3. 7 and negative 3, 7 to the right and negative 3, so somewhere around here. 4 and 3 would be 4 to the right and then 3 up. So this is what you would be looking for. This is what the distance, this is the distance that you'll be looking for, the distance between those 2 points. And notice it's a diagonal. So you would have to measure this leg and this leg. So allow me to make this triangle just a little bit. So here's the hypotenuse, and these are the values that you're missing. The value of that leg and the value of this leg. Now let's look at the points. The points, this point here is 7, negative 3, right? And this point is 4. Now if you want the horizontal distance, right? The horizontal, which is from here, and I'll change it. I'll put it here like this. If you want this distance over here, it's the distance between the x values. So if you look at the x value, so x is, you write x and y here, x and y. So to find that horizontal distance, you would just subtract the x value. So you go 4 minus 7, which is negative 3, and you know distance can't be negative, so you take the absolute value. So the distance between here, 4 and 7, is 3. Now, let me change colors for the vertical distance. The vertical distance is going to be the difference between the y values. And the distance between, so I'm going to write vertical distance, vertical. And the difference between the y values, where are the y values? Is 3 and negative 3. So you go 3 minus negative 3. And 3 minus negative 3 is the same thing as 3 plus 3, which gives you 6. So this is 6. Now you have all the information you need to find that diagonal. So you go a squared plus b squared equals c squared. Now let's call 6a and b3. So 6 to the second power plus 3 to the second power equals c squared. 36 plus 9 equals c squared. What is that? 45. Right, you take the square root of both sides, and c is going to be approximately square root of 45, 6.71. All right, so now, as you're doing this, right, I think when we did this in class, we noticed a little pattern here, right? And the pattern that you end up doing is that, well, you realize that you're going to find, so you're going to be subtracting, so let me call that the 2x values, right? And then you're going to raise that to the second power. And then the other thing you're doing is subtracting the y value, so let's just call that y2 minus y1. And you're going to take this, raise it to second power, right? And then you end up adding them, and then you end up taking the square root. And that ends up being the distance formula. So you can either remember that, or you can do it in parts like we did, and you don't have to worry about remembering this at all. Let's try the next one. Negative 7 and 1, negative 8 and 2. So again, just going to draw this out. Negative 7 and 1 would be 7 to the left and 1 up. So somewhere around here. Negative 8 and 2, it's even a little bit further. And then a little bit higher. So this one is actually very close. And I'm just going to make that a little bigger. So like the same thing, a little bigger. We're looking for this, which is the hypotenuse, right? So this is going to be what we're missing, what we're trying to find out. And we're looking to see what this leg is and this leg is. So for that one, and again, I'll separate this. Here's my horizontal value. My horizontal value, right, it's going to be the difference between the x value. So here's my x and y, x and y. So you subtract negative 7 minus negative 8. It's going to give you positive 1. So the horizontal value right here, it's 1. So this guy here, right, is 1. The vertical, up and down. So to find your vertical, you're going to subtract the y value. So you're going to do a 1 minus 2. Notice that in this case, you got negative 1. We're going to take the absolute value of that, and the height is also 1. So we have a triangle, one where the two legs are 1 each. So we go a squared plus b squared equals c squared. So notice what we're about to do. We're going to square both legs, right? We're going to add them. So 1 squared is 1 plus 1 squared, which is another 1. And once we add them, which we get 2 over here, right? 1 plus 1 is 2. We're going to take the square root of both sides. And c equals, and again, we could actually leave it in radical form, but because I didn't talk about that in class, we're going to leave it in decimal, 1.41 approx. Right, now, if you memorize the distance formula, which is the difference in x values, so x2 minus x1, plus the difference in y values, so the second power, and you'll notice that we did the same thing. So if you so let's do the x first. So the x, you got 1 minus 2, and then you raise to the second power plus, and then the y values, what were the y values? The x values. It's 7 minus negative 8, the second power, and the y values was 1 minus 2, raised to the second power, which equals, and again, look, you're going to get the same thing. 7 minus negative 8 is 1 to the second power. And I'll just do that automatically, which is 1, and then plus negative 1 to the second power. Negative 1 times negative 1 is just 1. And notice how we get the same thing, the square root of 2, which if you take it, you end up getting 1.41. So either you can remember that, or you can do it this way, up to you, right? So somebody found a pattern and realized that that's what they're doing, and then they decide, hey, here's a formula. I'll do a couple more, okay? Let's do 17. So 17, I want to imagine what 2 points look like, where they are. So 6 and 1 is 6 to the right and 1 up, right here. -3 and 8 would be -3 to the left and then 8 up. So we're looking at that. So that is sort of what these 2 points, and I want that distance, right? So let me just bring it out here, make it a little bit bigger so that you can see. I need this leg and I need this leg. Either you use this if you want. Okay, you're totally welcome to use this, right? Oops. y2 minus y1 plus second power. All right, or you do, and you break it up into pieces, and you end up doing the same thing. So I need this horizontal distance, right, between this point and this point. So this is what I'm going to work on. So in order to do that, I'm going to subtract my x values, which is what this would be. So the x values is, in this case, 6 and -3. So I do 6 minus -3, which is the same thing as 6 plus 3. So the horizontal value is 9. So I know this is 9. And I'll do the formula at the same time. So I am going to do 6 minus -3 to the second power. And then the second part would be the vertical, right? The vertical distance between these 2 points from here. I'm going to change from here. And to find that vertical distance, I'm going to do the difference between the y values. So we get 1 minus 8, which is -7. Take the absolute value of that, you get 7. So this is 7. And if I did it on this side, I would get, right, let's put up parentheses here. I would get 1 minus 8 to the second power. Let's see if we get the same thing. So 6 minus -3 is 9, and I get 9 to the second power. Here I'm going to get -7 to the second power, right? And on this side, the left side, I would go a squared plus b squared equals c squared. This is going to be my a, and this is going to be b, and c is the diagonal that I'm looking for. So a squared is 9 to the second power, b 7, sorry, take that back, a 7, so it'd be 7 squared plus b squared, which is 9, equals c squared. So notice that I'm doing, whether you're using this, right, break it up into pieces, or using the formula, it looks exactly the same. So 9 to the second power is 81 here. -7 times -7 is 49, right? You're going to add. Here's the same thing, 49 plus 81. Notice that we're almost at the same spot. 81 plus 49 is 130, right? And we have to take the square root of that. And we end up getting approximately, to the distance is approximately 11.4. And if you did it this way, notice what the next step is. We got to add those two, which gives me 130 equals c squared. Now I take the square root of this, square root of the left side and the right side, and I get that c is 11.4 about. So whether you do it this way, the left side, or using this formula is the same thing. Well, because this came from all that, right? So all this that we just did in parts eventually led to that. It's up to you to choose which way. So I'm going to not do this anymore because I'm going to do the other part. And I'm going to do the one that has these. Okay. All right, so let's look at that. They're asking us here to find the perimeter of this shape, which means this side plus this side plus this side plus this side, right? Now it says that each unit on the graph is equal to 10, so let's count. I mean, this I can count. This from here to here I can count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's 13 units, but we're multiplying by 10. That means this is 130 yards. Same thing at the bottom. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 100, also 130. So I want the perimeter. Perimeter is the sum of all the sides. We got 130 plus 130. Now this diagonal, I can't count it like this. 1, 2, 3, 4. I can't do that, right? So because it's not exactly the length of the square, so we have to find, and now erase, right? We have to find that distance. And this is what I'm looking at. I need to find this guy right here. Well, and that looks like the hypotenuse of a triangle. So let's draw a triangle out. Here's my triangle. And notice that our horizontal distance here, I can just count. This is 1, 2, 3, 4, 5, which makes, and let me draw that triangle to the side. Right, it was 5 units, but I multiply that 10, which makes this 50. Up and down, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 10, which makes that 120. So now I have to find C. Can I find C? I can. I'll do the Pythagorean theorem. So let's call this A, and let's call this B. So A squared plus B squared equals C squared. A is 120 to the second power plus 50 to the second power. C squared. 120 to the second power is 14,400. 50 to the second power is 2,500. And then if we add that, we're going to get 16,900 equals C squared. We're going to take the square root of both sides. And if you take the square root of that 16,900, you get 130. So C is 130. So now I know everything I need to know. So this diagonal is 130. This diagonal is also going to be 130. So now I have everything I need. So it's 130 plus 130 top and bottom. And the two diagonals are 130 each as well. So the perimeter is just 130 times 4, which gives me 520 yards. I know, it seems like very repetitive. It is. But this one, the extra layer here is this part right here, that every unit represents a different distance. So in this case, every unit is 15. Max threw a frisbee to Sam. Max, okay. If each unit on the graph, how many feet did the frisbee travel? Okay, so the feet. So now we can create. Let's find the legs. So we have our diagonal, our hypotenuse, and let's find the legs. So we need to find this, and we need to find this to then find C, our hypotenuse. Well, here we can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12, but each unit is 15, so you end up multiplying 12 times 15, which gives you that this is actually 180. Horizontal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11 times 15 gives you that this is 165. Now that we have both legs, call this A, call this B, and then we find C. So A squared plus B squared equals C squared, so 180 plus 165 to the second power equals C squared. So 180 to the second power is 11,664. 165 to the second power is 200. Wait a second. No, that's not right. 180 to the second power is 32,000. Apologies. 400. 165 to the second power is 27,225, which equals C squared. So now we got to add both of them, plus and you get 59,000. C squared is 59,625 equals C squared. Take the square root of both sides, and you get that C equals, let's take the square root of that, So this C is 244.18. Okay. So the extra layer here is just the fact that each unit measure is worth something different than the other. Thank God this doesn't want. So we have 3 people, and they're all going to Shelby's house, and we want to find the difference. Okay. If Shelby's going to visit a friend who lives in 12 miles, whose house is she going to? So one of these guys, Elise, Eva, and Kim live less than 12 miles away, and that's the friend that she's going to visit, but we need to find, right, the distance. So, again, you're going to do this 3 times, I know. But here's the first triangle. You need to find, here's my second triangle, or the 2 legs that you're going to use to find Ava's distance to Shelby. And I'll change it to orange, and the last triangle, orange, 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 all the way here, and these are the 2 legs that you're going to need to find in order to find the distance between Kim and Shelby. So let's do, in red, Elise. So this one you just have to count, right? So here's my triangle, Elise, right? Here's Elise. All right, Elise over here. We need to find C, and 1, 2, 3, so this, the y distance here is 3, x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this is 12. So you would do, so let's just do it. 3 squared plus 12 squared equals c squared. That is 9 plus 144 equals c squared. We got 153 equals c squared. Let's take the square root of both sides, and c, 153 square root of 153 is 12.36 approximately. 12.37 actually. So Elise is out because she lives more than 12 miles away. So it's not going to be Elise. Let's take the blue. Here's a triangle that represents Ava's distance to Shelby. And this is what we're missing. Right? We want to find the hypotenuse. So let's count blue. 1, 2, 3, 4. So this is 4. One of the legs is 4, and the other leg is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 4 squared plus 11 squared equals c squared. 16 plus 121 equals c squared. So 121 plus 16 is 137. We're going to take the square root of both sides. And we get that c is 11.7. 11.7. C is approximately 11.7. So she qualifies for a visit. So Ava here, it's only 11. So this is 11.07. This one was 12.37. So she's not going to visit Elise. She's going to visit Ava. I don't know if Kim falls in the category. So let's do Kim. This is what we're trying to find, the hypotenuse, and we need this leg, and we need this leg. So let's just count. 1, 2, 3, 4, 5. Up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so 11 squared plus 5 squared equals c squared. 121 plus 25 equals c squared. 146 equals c squared, square root of both sides, and we get that c is approximately square root of 146 equals 12.08. Oops, just a little too far for Shelby. So Shelby, this is 12.08, which means that Shelby is only going to visit Ava. Okay. What is this? Kevin went hiking, blah, 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 but he ended up at the lookout point instead. Every unit of the graph represents 0.5. How many miles will he need to hike from the lookout point to the waterfall? Okay, so this is where, okay, so Kevin is going to go from the lookout point right here, and he's going to the waterfall. So that's the distance that we want to know. Well, and we have these 2. Those are the 2 legs that we're missing. Now, it says here, well, let me draw the triangle here. So here is the triangle. This is the waterfall. And this is the lookout point, right? I'm just making it bigger. I don't have this leg, and I don't have this leg. That's what I need to find C, right, the distance. So now, if you count the units up and down, it's 2. But it says here that every unit is 0.5. So 2, times 0.5 equals 1. So this would be 1. And then from the horizontal distance is 1, 2, 3, 4, 5, 6. But it's 6 times 0.5, which makes it 3. So this is 3 miles. So 1 mile, 3 miles. So we get 1 squared plus 3 squared equals c squared. 1 plus 9 equals c squared. So 10 equals c squared. Take the square root of both sides, and c equals approx, again, 3.16 rounded. Okay? So nothing crazy, right? Nothing crazy. Lifeguard. What are you doing? Swim a loop from point A to point B, okay? And then point C, and then diagonally back to point A. Each unit in the graph represents 10 meters. How many? Okay, so he made a loop, so he's swimming this, then he's going like this, and then he's going back to point A. So that, and he keeps repeating that. So let's find from point A to point B is 1, 2, 3, 4, but it says that each unit is 10 meters. So instead of 4, you're going to write 40 over here. From point B to point C is 3 units, but 3 times 10, which makes this 30. And this is what we need to find the hypotenuse, right? Well, we can do that. So 40 squared plus 30 squared equals c squared. 1600 plus 900 equals c squared. So that's give us 2500, right? Equals c squared. We're going to take the square root of both sides. And x, or c, equals 50. So this is 50. So 250 meters. I think it's meters. Yeah. So she did this 3 times. Also, the first loop she swims 40. Then she swims 30. And then she goes a diagonal and swims 50. That equals to 120 meters. But she does that 3 times. That's a loop. So in total, how much did she swim? 360 meters. Okay. Each loop is 120. This one, the graph shows the view, blah, blah, blah. Each unit on the graph represents 2 inches. Okay. What is the perimeter of the desk? So perimeter means I want this, I want plus this, plus this, and plus this, right? All the sides of this trapezoid added up will give me the perimeter. Well, let's get rid of the 2 sides that I can. So from here to here, I can measure very easily. 1, 2, 3, 4, 5, 6. Every unit is 2, so 6 times 2 gives me 12. So this guy here is 12. The bottom, same thing. What is that? Negative 9 to positive 9, so that would be 18. 18 times 2 is 36. So this right here is 36. Now, I need to find the diagonal. Well, that diagonal, we need to use the leg. So here, let me give you the 2 legs that you're going to need in order to find that diagonal. So this is leg 1 and leg 2. So up and down, it's 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. 1, 2, sorry, take it back. That's not 8, because I forgot to multiply by 2, so that makes it 16 over here. And then 1, 2, 3, 4, 5, 6. Horizontally, 6 times 2 is 12. So there's my two legs that I needed to find the hypotenuse. So 12 squared plus 16 squared equals c squared. 144 plus 256 equals c squared plus 144. So we gotta add those 2 up. We get 400 equals c squared. Take the square root of both sides, and c equals 20. So this diagonal is 20. So will this diagonal, if you measure, is the same. The 2 legs are the same. So now I have everything I need to find the perimeter. So the perimeter is 12 plus the 2 20s plus the base at the bottom. So that's 36. So 8, 3, 5, 88. So the total perimeter is 88 inches. What is this? To get in shape for basketball trials, Tyrese runs sprints from the mailbox to the stop sign, back to the sign and back. Each unit of the graph represents 5 meters. Okay, if he ran that 10 times, how many meters did he run? All right, so that's what he's running, so we need to find that distance, and in order to do that, we can create a triangle here, a right angle triangle. Right, so this is leg A, leg B, and we're looking for C. So each unit of the graph represents 5. That's okay. So let's calculate this the vertical distance. So it's 1, 2, 3, 4 units, but it's times 5, which in reality makes this 20 meters. And then from here, let me change colors. From here, from the mailbox, the horizontal distance is 1, 2, 3, 4, 5, 6, 7. But we're going to go to 7 times 5, which makes this be, in real life, 35 meters. Now we have the triangle. Let me just clean that up a little bit. This is my right angle. We said that this was 20 and this was 35 meters. And we're looking for the hypotenuse, because that's the actual distance that he ran, right, from the mailbox to the stop sign. So 20 squared plus 35 squared equals c squared. 400 plus 1,225 equals c squared. 625 equals c squared. We're going to take the square root. And c equals, let's take the square root of that. We're going to get approximately 40.31 meters. So this distance that he's actually run is 40.31. But he did this how many times? Went to stop sign and back 10 times. He went to stop sign and back 10 times. So he did. So would be going to the mailbox and then coming back to the to the stop sign. That's 1. That means that he did 10 round trips. So if that's the case, right? He's at the stop sign. Sorry, he's at the mailbox. Goes to the stop sign. That's 40.31, and then comes back. That would be 80.62. If that counts as 1, and he repeats that 10 times, so it's actually 40.31, right? Plus 40.31, because he has to go to the stop sign and come back. So that's 80.62. So if he does this, think of it as 1 trip, and he does that 10 times, then we multiply that by 10. And we're going to get 806.2, if that's the case. Or if you just count, I don't know what the answer is. It depends on how you interpret this particular section right here. Okay, 2 more questions. What is this? The graph shows the distance between coys. Okay. Each unit of the graph represents 1 mile. Which restaurant is within 10 miles? Okay, so we're good here. So we want, in order to find the burger menu, which is this diagonal line here, we need the 2 legs. So I need this leg and I need this leg. Now this is easy enough that I don't have to subtract x, y, and y. You can. I'm just going to count. 1, 2, 3, 4, 5, 6. So this is 6, and this is 8. So we can quickly do 6 squared plus 8 squared equals c squared, right? Which is the diagonal here. So that's 36 plus 64 equals c squared. So 100 equals c squared. Take the square root of both sides. And in this case, c equals 10. So this guy is 10 miles. On the right side, pizza place. We need the 2 legs to find the hypotenuse again, right? So to find the hypotenuse, that diagonal, I need these 2 legs. And c is what I want. So this 1, 2, 3, 4, 5, 6, 7. This is 7. 1, 2, 3, 4, 5, 6, 7. This is also 7. So 7 squared plus 7 squared equals c squared. So we get 49 plus 49 equals 6. C squared. 98. equals c squared. Take the square root of both sides, and c equals approximately, no idea, 9.90. 9.9 approx. Okay, so what's the question? Within 10 miles? Well, really? You have to, they're both within 10, well, they're both within 10 miles, yeah? Or within means under 10 miles, which would be the pizza place. Last one. Graph shows the path of John and Miles canoe down the river. Okay, start to finish. The goal was to canoe at least 14 miles. Each unit on the graph represents 1 mile. Which of the following is a true statement? We don't have the statements, but I'm just going to do it anyway. This is what they canoed, so let me just find the legs that I need to solve this. Now, for this one, I'll use the points. This is the point 6, 2. And this is the point -7, 4. So, if you wanted to find the horizontal distance, right? This is the difference between the x values. So you would get -7 minus 6, which gets you -13, or take the absolute value, and that gives me 13. So this guy over here is 13. Up and down, the vertical distance is the difference between the y values. So we get 2 minus 4, right, this is -4, 2 minus, 2 minus -4, it's the same thing as 2 plus 4, which gives me 6. No, this is -7 and -4, good, and this is 6 and negative, hang on. Sorry. 6 and -4. What am I doing here? 6 and -4. No, apologies. 6 and 2, I was correct. Oh, I'm looking for the vertical distance. So it'd be -4. Start again. Apologies. I'm going to use this is -4. It's -4 minus, and the other y value is 2, which gives me -6. Take the absolute value, that gives me 6. So this guy is 6. Now you could have just counted 1, 2, 3, 4, 5, 6. Now we have a triangle, and you can find C. So 13 squared plus 6 squared equals C squared. This is 36. 13 squared is 169. Oops. 169 plus 36 equals C squared. It gives 12.5 equals C squared. Take the square root of both sides, and we get that C is 14.32 rounded. So 14, so C equals 14.32 rounded. I don't know what the statements were, but I'm just doing the question, so you could have skipped this one. Okay, that's it.